Hello students, we are still on circle geometry. Now we are moving on to cyclic quadrilateral. Cyclic quadrilateral. Now when you talk of cyclic quadrilateral, when you know a quadrilateral is a plane figure bounded by four sides. So if this is bounded by four sides, 1, 2, 3, 4, this is a quadrilateral. And if that quadrilateral is now placed inside the circle, that is what we mean by cyclic quadrilateral. So if you have a quadrilateral that is placed inside the circle is a cyclic quadrilateral. The opposite angles of a cyclic quadrilateral are supplementary. That means they are add up to 180 degrees. So in the opposite side, if this is a quadrilateral that is inside the circle, so this opposite angle and this angle, if you add it together, it should give you 180. So angle x plus angle y should be equal to 180. X plus y is equal to 180. Likewise, if you add angle m plus angle n, it should be equal to 180. M plus n is equal to 180. Then another rule says that the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. The exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. You know, you say if this angle and this angle, this is a quadrilateral, this angle and this angle, they are opposite angles of a cyclic quadrilateral. That means they should add up to 180 degrees. So if you are having x1 plus y1 should be equal to 180 degrees. Also, if you now have this to be a straight line, this y plus this x2 should be equal to 1 because that will give us angle on a straight line. X2 plus y is equal to 180, the angle on a straight line. So you can see that the value for angle x1 and x2 will be equal. This is the exterior angle for this interior angle of the opposite. So the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So this opposite of this angle is interior angle to this. So then this angle and this angle are going to be equal. Angle x1 is equal to angle x2. Now let's do some examples. Now if you have this, so this is in the diagram. CE is the diameter of the circle ABCDE. So CE, so this is the center of the circle, this is the diameter. If ABC, this angle at the circumference is equal to 127 degrees, find ACE. You are told to go ACE, you are told to look for this angle. Now before you look for this angle, you realize that this angle, if you have this 1, 2, 3, 4, this form a quadrilateral plane figure with four sides like this. So it means that so if you're having a quadrilateral inside the circle, the opposite angle should be equal to, if you add the two opposite angle, should be equal to 180 degrees. So this angle 127 plus this angle ADC, this particular angle should be equal to 180. Why? Opposite angles of cyclic quadrilateral. You must always give the reason before you are marked right. So ADC will now be equal to 180. This 127, bring it to this side, now turn to minus 127. 180 minus 127 will give you 53 degrees. Now, it means this angle is 53 degrees. Now, you realize that we are told that this line from here to here is a diameter. And we have learnt from one of the rules that the angle of a semicircle should be equal to a semicircle mixed with the circumference should be equal to 90 degrees. So if this is the diameter, so these two lines, so this line, this angle like this, you can see that if this is diameter, the angle it makes with the circumference is here. So the whole of this angle here, that is angle EDC. The whole of the EDC here should be equal to 90 degrees. So that means EDC, the whole of this angle here should be 90 degree. Now, and you know already we have looked for ADC, the angle here is 53. So from there, and we know that from this whole angle is 90. So the angle this place plus this place should add up to what? 90 degrees. So angle EDA plus ADC should be equal to what? EDC. And EDC is what? 90 degree. So from there you look for EDA. So this angle here. This angle we don't know. Plus this angle we have calculated this one to be what? 53. So this angle plus this angle 53 should be equal to 90 degrees. So that means this 53 when it comes here now turn to minus 53. 90 minus 53 is 37. So the angle here should be equal to 37 degrees. Now we are told to look for this place, not this place. You will notice something. So this angle touches the circumference P. So where is the origin? So you start from this point and this point. That's where it touches the circumference here. So from this same 2 points again, you have another one touching the circumference this way. So this angle here and this angle here are angles of the same segment. So the angle we are told to look for, which is ACE, should be equal to angle AEDA, because they have the same origin. They are starting from the same point. So that this angle here and this angle here should be equal. And since we've looked for this angle here to be 37, so that means our angle ACE that we are told to look for is also 37 degrees. Now, let's consider this second example. Let's consider this second example. Now, in the diagram, PQRS are points on the circle of center O, the center O, PQRS. So QP is produced to X if XPX is 77 degrees and PSO is 68 degrees. Find PQO. We are told to look for this angle here. Now, this angle here. Now, first of all, if before you can look for this angle, now let's take this to be angle on a straight line. Angle QPS and XPS. So this angle here, the angle here plus this angle here, this angle on a straight line. So when you add QPS, this angle here plus this place plus 77 should give be equal to 180. Why? Angle on a straight line. So from there, if you bring this plus 77 to this other side, whenever plus crosses equality sign, it turn to minus 77. So 180 minus 77 is equal to 103 degrees. So the angle here is 103 degrees. From here, we will be able to look for the angle that is here. We need to look for the angle that is here. So how are we going to look for the angle that is here? Now, we realize that if you look at it, this one line, 2, 3, 4. So these 4 lines forms a cyclic quadrilateral. You can see that it forms a cyclic quadrilateral bounded by 4 sides. Are you following me? So this 1, 2, 3, 4. So it forms a cyclic quadrilateral. So it means that the angle here and the angle here, when you add them together, it should give you 180 because opposite angles of cyclic quadrilateral are equal. So angle QPS plus angle QRS should be equal to 180. State the reason. Opposite angles of a cyclic quadrilateral. So our this angle here QPS, which we have looked for earlier, which is 103, plus this new one we are looking for should be equal to 180. So QRS will now be, if you bring this one, when you bring it to this other side, now turn to minus 103. 180 minus 103 will give you 77 degrees. Now it means this angle is 77 degrees. So from here we can look for the angle that is here. Realize this is the angle at the center. This one and this one are radius, angle at the center. So starting from these 2 points again, where you having this sector, this angle at the center, we have another one touching the circumference, making what? This one will be the angle at the circumference from this angle at the center. And we said that for this angle at the center, it means that to get angle at the circumference, your angle at the center, when you are given angle at the circumference, you multiply the circumference by 2 to get this. So since we have been able to calculate QRS to be 77, so to get QOS, so you multiply this 77 by 2 to get the one at the center, which is 2 times 77. We give the reason. Angle at the center is twice angle at circumference, which is equal to 154 degrees. So the angle here is 154 degrees. Now, generally, the sum of angles in a quadrilateral should be equal to 360 degrees. You realize that we've calculated this one to be what? 103. This angle is 68. We've calculated this angle to be 103. This angle is 68. Then we've calculated this one to be also be 154. So then it made this fourth. So if you now take this one to be a quadrilateral, 1, 2, 3, 4. Sum of angles in a quadrilateral generally is what? 360. So when we add what? This 103 we calculated here for this angle here, plus 68 for this one, plus this angle at center here, which is what? 154, plus the angle we are told to look for, which is PQO. PQO should be equal to 360. Why? Sum of angles in a quadrilateral. So 103 plus 68 plus 154 will give 325, plus PQO is equal to 360. So from there, bring this 325 to this side, now turn to minus. 360 minus 325 is what? 35 degrees. So from there, we'll be able to get what we are looking for. So as for your work practice, now let's do this. Find the lettered angles. In this circle, you are given a triangle like this, and it is cut at this point. So you are totally for A, B, C, D, and E. This angle is 62, this angle is 85. For this one, so this is angle is 80, 20. You are totally for F. Then for this, you are having this angle is 18, the whole of this is 78, this angle is 42. You are totally for G. Then for this one, you are told that this angle is H, this is 2H. You are told that this is 60. So that means look for the value of H and 2H. Then here you are told to look for this angle is 98 and this is 43. You are told to look for this place, which is I. Then here you are given this to be 83, this is 55. So you are told to look for this place, J. So make sure you like, subscribe, and comment on this video.